Question 7. A lot of marks here, 16 marks to play with, so we're likely going to have to do quite a bit of work. The curver's equation, show that the curve has exactly two stationary points and find the exact values of their coordinates. So what we need to do is, stationary points are when the differential equals 0. So the first thing we're going to have to do is find out what that is. Now we're going to use this part. Now u we're going to put as x squared, v is going to be e to the minus x over 4. So u dash then is 2x, and v dash, we're differentiating, so the minus will come down. So it'll be minus a quarter e to the minus x over 4. So then y dash will equal u, which is x squared, times by a quarter e to the minus x over 4, plus then u dash is 2x, and v is e to the minus x over 4. So doing nothing much really, you're just rearranging that to make it look slightly more normal to what it does. So when we've got that, then what's our next step? Well, first of all, you realise I've made a little error here. I've lost my minus, so minus is in there. Now I'm going to set this then equal to 0. So dy dx equals 0 implies stat points. So 0 equals minus a quarter x squared e to the minus x over 4 plus 2x e to the minus x over 4. So first thing we can do is times out, or work out here what we can times out here. So I can times out 4 and get rid of that. So then that will give me 8x e to the x over 4 minus, and at this point here, well, that's now timesing by 4 means that's gone. So we've just got x squared e to the x over 4. If I then take a factor out of e to the minus x squared, just to see if that helps us at all, I've then got 8x minus x squared. Now can we make this 0? No, because e is never 0. So I'm just going to take a copy of this line here and then continue that on the next slide. So we're then left with, so just write down the fact that e to the minus x never equals 0. So that implies then that we've got x squared equals 0. X squared, you can't just divide through by x there, so now we've got to take out a factor of x, which is then 8 minus x equals 0. So x then can equal 0, or it can equal 8, and what it wants is it wants the coordinates, so the exact values of the coordinates. So we've got 0 then. Now when 0 goes into there, that will just give us 0, and then when 8 goes in, that will give us 64 e to the minus 2. So there are our coordinates. Just double checking on this bit. And that's worked out fine. B part 1 then states to use integration by parts twice to find the exact value. So this again is really tough, using it twice. So the first thing to do is be very clear on what we have here. So it's uv minus and then v u dash, and that's dx. So what we're looking to do here is decide what our x and our y are going to be. Sorry, our u and our v are going to be. So we're going to put down u as x squared, and v then is going to be e to the minus x over 4, and that's our v dash. So differentiating this gives us 2x. Integrating this gives us minus 4e to the x to the 4. At that point then, we're then going to sub it into here. So we then get the integral of what we're trying to find, which is with respect to 4 and 0. So uv and then minus the integral between 4 and 0. Now v this time is minus 4e to the minus 4x, and then u dash is 2x. Now we're told, and we were sort of pre-warned in a way, that we've got this part here. Now I'm just going to do this without the limits at the moment, so I'm going to make it a bit easier, and then we'll put the limits in right at the end. This will become a plus. We can take 8 outside the integral, and then we're left with x e to the x over 4. So again, I'll just take a copy of this and take this onto the next slide. Just move that bit off the page, that's the thing I'm interested in. So again, it has said that we'll need to use it twice, so we'll use u is equal to x, v dash is equal to e to the minus x over 4. We've then got that u dash equals 1, v is equal to minus 4e to the minus x over 4. So just for this part here, we're looking then at the integral of this, using by parts, is uv, so it's minus 4x e to the minus x over 4, and then minus the integral of v u dash, so we've then got minus 4e x over 4. Now that can be integrated then itself. So that then becomes a plus. Bringing this down then makes it a minus again. So we then got minus 16 e minus x over 4. And what we're then looking to do is put the different bits together. So I'm just going to pull back what we had up here. So we've taken this part here, which I've actually got already here, haven't I? So I've got it at the top here. So if we put it all together then, the big integral overall, and we're wanting to sub in I think 4 and 0, would then be equal to minus 4x squared e to minus x over 4, and then this here we've separated up to make this, so we've then got minus 4x e to the x over 4, and then minus 16 e to the minus x over 4, just a minus, and then we should have. And then we start looking at subbing in. Now I've made a slight error here because here this integral, and it's harder with on the screen here because I'm writing, it's not natural, so I've got the 8 lots of this, so this would actually be 8 times bigger. So that would be 32. And then 8 16ths, double it, and double it again, is 128. Now at that point then, we're then going to sub in 4 and 0 into there. So that then will give us minus, that's 16 times by 4, which is 64, e to the minus 1, minus 4 times your 32, which is going to be 128 e to the minus 1, and then minus 128 e to the minus 1, and then minus, now putting 0 in to everything apart from the end bit will give us nothing because the x is at the front. Putting 0 into this part, e to the 0 is 1, so that then gives us a minus 128. Make a copy of this. Which then gets to the point of going, right, okay, we've got a lot of minus e to the 1s here. So we've got 64, minus 128, another minus there. So if we take them all off, then that'll give us minus 320 e to the minus 1. And then we've got minus and minus there, which is a plus. So that'll give us 128 minus 320 over e. And you get there. Then the region is bound. We've then got a separate question for part 2, but it's obviously connected because it's part 2 there, so it will be using it. Bounded by the curve here, and the x-axis rotated through there. So we've then got the integral between 4 and 0 of pi and then x squared. So we have this area here, 3x e to the minus 8 all squared. So we're going to set the pi on the outside. Squaring 3x will give us 9x squared. This bit, how do you think they do that then? Well, it's just that times by itself. So if you're timesing that by itself, you can actually use the rule that you times the powers together. So it leaves you with e then dx over 4, because the 2 then will cancel with that. When they brackets, it means that you can times indices, and that's then dx. Now surprisingly, that is directly connected to what we had before, but I'm just going to take my 9 pi out here. So we then get, this is exactly the part that we'd worked out from previously, so then it's just 9 pi times by our answer to the previous question. Very, very tough.